and he's going to put a lot of sort of meat on the bones of all the technical stuff. So I'm kind of sort of Ron's fluffer, I guess, if you like. So I'll get you all warmed up, and then Ron will. I was going to say finish you off, but that's just a bit too wrong, isn't it? Anyway, as we go on. So for 10 years or so, Fortec have been developing non-stop software solutions on third-party systems, mainly HP's stuff. We're an alliance partner with those, and that gives us a certain level of access. But as we grew, new projects, we've got lots of new projects underway, new products coming along. We needed more development resource, so we decided to look into getting our own system, and this is basically sort of how we did it. Okay, come on, next slide. Okay, here we go. So Fortec developed solutions solely for the HP non-stop. Panfinder's the only non-stop centric payment card data discovery tool in the market. It's been out there for sort of 10 years, essential for regulatory compliance, and we've got loads of happy customers all over the world. Our integrity detective solution was scoped out and spec'd by one of the leading non-stop security engineers in the industry, namely Greg Swedosh. I'm sure most of you have heard of him. He's been sort of doing security configurations and security admin on systems all over the world for decades, and he's one of the Fortec guys as well. So basically, we put together a set of file and system monitoring functionality that is basically the core stuff of what you need. It's non-stop based, it's real time, it's got enterprise connectivity, and we've recently, actually, we're quite proud to announce that we've recently just signed up with a HP Marketplace, so all of your Fortec solutions are now going to be available directly from HP. So all of this really sort of led us on to sort of needing more sort of development resource ourselves. So why would we get our own system? So I say we develop all of it in-house. We're a Silver Alliance partner, and that gives us a certain amount of access. But to extend that to the full year is actually quite cost prohibitive, or it was for us anyway, we thought. So we started chats with HP, and they were on board with us from day one. Actually, they've been a great partner in this. And I can only say, you know, that the help and assistance that we've got has been absolutely first rate. And we pretty much came down to the only solution for us was to run our own in-house system, because part of what you have to do as an alliance partner when you develop products is you have to get them certified on all the different levels of HP's hardware. So we wanted to leave our sort of Silver Alliance partner access for us to get sort of our incremental sort of annual access to all the different systems that HP have for that kind of cross-platform testing, if you like, which left us really, we needed to do our own thing. So why go virtual then? Which system to choose? If we're going to go converged, do we go old or new? And that pretty much answered itself, really. We didn't want to be developing new solutions on old versions of the OS. We wanted the latest OSs. And some of the bigger systems, you know, we're a development shop. Some of the bigger systems, as I say, were really sort of cost prohibitive and too much for us, really, for what we needed. Too much system, really, at all. So virtual gave us a lot of options from both HPE and other suppliers. Ease of housing it as well. It's pretty small, as you can see from the first picture. We kind of done something a little bit different with where we keep ours. And future expansion is fairly straightforward with a vNS, as we found out as well. So that was our solution of how we came to deciding we were going to go virtual. So then it was a case of how do we get all the appropriate knowledge? Now, yes, we've got a lot of in-house systems management knowledge and experience, and we've got a lot of in-house development experience. But you know, we've got no real hardware experience. We're not network folks, all of that kind of thing. So we needed to get the right people around us, and that discussion started with Graham Rogers at HP. We spoke to Graham. They'd done, obviously, you know, a lot of work with virtual, and they'd used Ron Meijer at Continuous to do a lot of the sort of technical sort of heavy lifting there. So we very quickly got into a conversation with Ron. And I've got to say, this presentation will probably blow quite a bit of smoke up Ron's, was asked, am I allowed to say that? But he really, there is nothing this guy doesn't know about hardware, about compatibility of different pieces of hardware, about the non-stop, about just sort of good old-fashioned tandem stuff in general. So it was a great asset to our sort of little project. And that led us down the spec then of talking about, you know, what spec our system would be. Obviously, it's DL380 based, you know, HP sort of rack server. And we looked at sort of Gen 8, Gen 9 and Gen 10. And Ron sort of steered us away quite quickly from a Gen 8. And then really it comes down to cost. As you say, I've got eBay on there. We did a lot of our shopping on eBay at first. And you can buy a Gen 8 DL380 for a couple of £100. Gen 9s are normally go to a couple of £1,000, and Gen 10s are sort of like about £20,000. They were when we were shopping for them anyway. So we started looking around. We spoke to a few sort of general hardware suppliers, and to be honest, they were just really difficult to deal with, if I'm being polite. So we went back to eBay, and all the individual components that we'd sort of laid out that we needed were all available. It's bizarre, actually. You can buy anything on eBay. But that led us through that to a company called IT in Stock. And they're basically, I guess they buy old hardware off people, they refurbish it, recondition it, and then they sell all the individual components, or they put it together for you, or whatever. And they were fantastic. So that was basically our team: HP, Continuous, and IT in Stock. So backwards and forwards, like I say, we went with Ron and with IT in Stock, basically on specifications of different controllers and adapters. And again, this is where Ron is great. I mean, he can quote part numbers, and he knows into part number compatibilities and things like that. It was unbelievable, actually, the depth of knowledge he's got. So, and working with the IT, so even some of the things we thought would be really hard to get, they had, and it was like, you know, really sort of cost effective and cheap for us and everything. So we did that's basically what's on the screen now, is the spec of what we've got. I've had quite a few people actually ask me for more details on that, you know, and you know, the quotes that we got and all that kind of thing, and I'm happy to sort of pass that kind of stuff on, you know, offline afterwards if anyone's interested. So the cost for all of that, so for our two Gen 9 DL380s, the cost for all that came in at just under £8,000 delivered. They had it built and tested. Once we decided on the spec, they build it all up, they give it a test, and it was ready to go in a couple of days. Like I say, it's all none of it's brand new, apart from the UPS. The UPS was brand new. Everybody said don't buy second-hand batteries, so we bought a new UPS. But it's all warranted. It's all 12 and 24-month warranties, depending on the part. So we were happy with that. So then they shipped it off via UPS to Ron in the Netherlands, where it frankly got lost. And quite a worrying and scary couple of days of us dealing with UPS and IT in Stock. Ron was phoning the local UPS. And it wasn't until someone tried to get out of one of the fire doors in Ron's building that they realized they'd actually left it outside for 2 days, lent up against a fire door. But anyway, thankfully, it was all okay. Everything was worked okay. Ron got it, wasted no time in getting it all set up and fired up. And Ron will take you through the process of actually all of the technical intricacies of that in his part at the end of his presentation. So I'll... like I say, I'm just kind of warming up for Ron, really. So once all done, Ron took about a week or so to do that from memory. Obviously, he's got his all of his other regular day job stuff he was doing as well. We decided we weren't going to ship it anymore, so I actually drove over to collect it. Got up early one morning, drove down across on the tunnel, up to the Netherlands. Got to Ron's place. Great, they've got a great facility, Continuous. I got a bit of a tour. And then Ron went through bringing up the system, bringing the system down. He'd done some pretty good instructions for us as well. I mean, any of you that know me, I'm not technical at all. Anything outside of a PC and my phone, I'm not your guy, really. So I was pretty impressed with myself, to be fair. that we managed to follow all of this. But I say all down to sort of Ron making it, you know, really plug and play kind of easy, really. So we bought it back and went through all the various bits and bobs of that. So we got the system back home. Oh, hang on, page up, and sort of stepping back a little bit now. We'd looked at various options for housing the system, you know, and the factors really were cost, accessibility, obviously internet speed, but the resilience of the hardware as well. You looked at some of the specs of how hot this stuff can run or how cold it can be, and we think all, you know, all these sort of, you know, sealed up data centers with air conditioning, all this kind of thing. And really, in our experience, we found that's just not really required at all. I've got really good internet connection at my house. I've got fiber optic all the way to my house. I've got a decent sized workshop in my back garden. So we thought, you know what, let's clear out a corner of that and install it there, really. My son's been an electrician all of his career. So he came round and ran a load of power cables and network cables and all that kind of stuff. It was great actually finally getting a bit of a return on my fathering investment there. He actually did something useful. Now he's great. So then it basically came down to getting the whole thing installed. So it was back onto eBay. I bought myself an RJ45 crimp tool, a load of RJ45 connectors, a roll of cable, a load of the specific rack mount nuts and bolts that fit in those little square holes that you can see there. You have to have special things, like who knew, but you know, we found that out. And I've downloaded an RJ45 pin out wiring diagram, and then Ron's instructions, and off we went. So that took about a day. Myself and Dan Lewis went through, made all the patch cables up. It was quite therapeutic actually. Got it all up and running. We put a network switch in. Obviously, the network had kind of comes into my house to a router that's in my sort of on the front of my house. Then the cable goes from there up into my loft, where it goes through a network switch that does all of the networking stuff in my house and CCTV and stuff. And then there's, you know, it leads back out, goes out to the workshop, and then we've got another network switch that splits that off and runs all of this. I put a wireless repeater in there as well. We got all the UPS installed and configured. No instructions with that. Nothing comes with instructions. I don't understand why this, you know, you normally buy something in a box, it comes with instructions. I mean, you know, and these things, it's, you know, the UPS, it's not like an iPhone where you just get it out, switch it on and just somehow instinctively know how it works. But a few sort of, you know, YouTube videos, and we got the UPS up and running and configured. And it had been tested a couple of times actually, not on purpose. I've, you know, switched off the wrong breaker a couple of times and everything, but everything runs okay. It does what it needs to do. So we were happy with that. So then up it came. So following Ron's instructions, we fired it up. OSM startup tool was launched. We configured 6530 terminal emulator, and everything started up as it should with no problems at all. Like I said, we've got a lot of some in-house systems management experience. So we obviously did all the sort of systems management of all of that ourselves. Got it all going. You can see there, dsmscm.greg Swedish did all of that. But then, so that was basically the connection from within our four walls sorted once the system was up. But obviously, for this part as well, to get Greg online, I obviously need, he's in Australia. I had to open up some port access to let sort of, you know, external folks in. And this is kind of where we were a bit sort of overzealous and a bit excited, and it didn't go horribly wrong, but it went a little bit wrong. The firewall in the basic route you can see in the picture there in the bottom right hand, the black box, that's the basic router you get from Virgin, and the firewall on that basically has two settings, on or off, and the only thing you can really do is open up certain ports. So stupidly, we opened up a couple of ports to let the external guys in. So, you know, Greg got on, he did everything he needed to do and all this kind of stuff, and it was all fine. A couple of days later, we noticed really, and this kind of goes back a little bit to John Bycroft's presentation, literally millions of access attempts. It was pretty scary actually, and I think, you know, security by obscurity. They didn't really know what was on the other end, and thankfully we didn't get a breach, but we pretty much knew we had to do something about it. So again, back onto the internet, did some research and came up with a company called WatchGuard, and they have got a firebox range of firewalls, and they do everything from the small ones you can see in the picture, which we used, up to big rack mounted ones, and the difference is being their throughput ability, how many concurrent VPN sessions you can do, and all this kind of stuff. So we got that. We bought one of those. Again, though, it was a couple of £100, and then you pay. I think we paid like a 5-year subscription for the software and support that goes on it, which was, I think, about another 500 or 600. Now the installation was a doddle. You do literally plug it in, switch it on, and off it goes. The configuration, though, was on another level of difficult. Now, bear in mind, there's only me doing the configuration, because it had to be someone from within my 4 walls doing it. I've got no network experience really of doing these firewalls, and I mean, literally, I mean, all the people, the techie guys on here will know, you know, the amount of different pages and configurations. I mean, there's literally thousands of things you can configure on this thing. It's too configurable, really. You know, I was thinking, you know, come back on, off, you know, all is forgiven. But thankfully, the support was pretty good. We did about 3 different Zoom sessions to get everything fired up. So everything in my house obviously needs to work and function on one sort of subnet, if you like, and then everything to do with the non-stop is on another one, and all the VPN comes in just to that, and all that kind of thing. We had a few issues with one of our developer guys was using an Apple Mac with a Windows emulator on it, and then and that caused some issues, but we got all that sorted, and it all works perfectly fine now. So you see that it lives in my front room. So I get asked about sort of running costs and temperatures and all that kind of thing a lot. The whole system consumes 11 kilowatt hours of electricity a day. We had, when my son did all the electrical installation, we installed a kilowatt hour meter for that circuit, so we can sort of monitor it. So that works out on the current tariff I'm paying, that works out to just over £2 a day, or sort of £773 a year, roughly. The temperature in the workshop has varied hugely. There's no heating or air conditioning there or anything. So since the system's been running for about 7 months, the temperature's gone from about -5 to a +30. That it was in there last week when it was warm, and the server sort of copes fine. If you look at the picture in the top left there, the temperature graph, you can see, I mean, the system monitors the temperature in a load of different places. You can see the top one is the inlet ambient temperature, so that had got a 30-degree reading, and then you can see the hottest component is number 24, an I/O board, which is running at 75, but there's the caution for that component isn't till 100, and there isn't a critical, so I don't know if that just means, you know, it goes on for as hot as you like, but you know, whatever. But that literally is as hot as it's ever got. At the bottom you can see it's obviously got the 6 sort of interchangeable fans that all vary their speed. The fans are not much more than ticking over really at those temperatures, so we haven't really, you know, we're not worried. I mean, we did, when we were doing the electric, we installed sort of some extra power so that we could, you know, run some AC if required. But to be fair, we're kind of thinking it's just fine. And, you know, it's ran perfectly fine ever since we first sort of switched it on. So we're looking that the project was a total success. I've heard quite a few people mention to me, I wasn't in the presentation, but apparently a couple of years ago at boot camp, there was a presentation that said that this process was difficult and don't try it on your own and all this kind of thing. Well, I have to say that, you know, we couldn't be further from the truth with us. I mean, yes, we had the right people around us helping, but the whole process was actually really quite easy. The total outlay for everything, including shipping, travel, consultancy fees, was around about 13,500. Yeah, all the hardware was secondhand, as I've said. You know, everything came with warranty, and it ran absolutely faultlessly from day one, really. So yeah, we can't complain. So before I hand over to Ron, I just wanted to say sort of really thanks to everybody that were involved. Neil and Graham, Kevin McGough helped get us set up as a new name non-stop customer. Ron, obviously continuous. I know I've spoke his praises enough. WatchGuard for their firewalls, IT Insight, my son for his electrical expertise, and that was that. Our development and QA is now quicker and more in depth. Our access speeds are a lot quicker than we ever had before, and yeah, that was it really. It was, like I say, it was a complete success. And I'll now hand over to Ron. Ron, if I stop sharing and you want to share your screen, I think it'll come over to you, and Ron will tell you all the clever stuff that I quickly shot over there.
Thank you very much, Sean. You have very intelligent pets at home.
yeah, into dogs and cats.
Nice. Dogs and cats, and they can live together.
Indeed.
Yeah, they can. Okay, great. Let's see if I can find the right button over here to share my screen. That's the button. That's the screen which I need. Are you all able to see this?
Yes.
Wonderful.
It's not in presentation view though, Ron. We're just seeing the sort of PowerPoint screen.
That's the problem when you have two screens. So I have to select the other one. Try one more time. There we go.
I'll mute myself once we're all up and running. So, okay, just see your PC screen now.
There we go.
There you go. Yeah, perfect.
Let's organize myself a little bit. Thank you very much, Saul. Indeed. The guys from the BITAC, they have asked me to give a presentation about our project with Vortex software. And that is what I'm going to do in the next, let's say, half an hour. I cannot go that much into depth because we only have a half an hour, something around a half an hour. But yeah, let's see what we have in this presentation. First of all, I have to say it was really nice to work together with Shaw's team, with Vortex software, and also with HPE. It was really relaxed. There was no pressure. We had a couple of very nice conf calls about this project, and yeah, it went in fact pretty smooth with not much hurdles. In fact, there was only one hurdle, and that was the fact that the hardware was lost, as Sean said, but we found it after 2 or 3 days, so that was good. I have a short agenda. I'm going to introduce myself. I'm going to talk about the virtualized nonstop journey I took over the last couple of years, and of course the journey which we took in last year with Vortex software. I'm going to discuss a little bit with you the converged and virtualized nonstop architecture. Converged means our physical boxes, NS3, NS7, NS4, NS8 systems. And I'm going to tell you what is needed to build a virtualized nonstop. After that, I'm going to discuss with you very quickly the hardware availability level. So which choices do you have when you're going to build a virtualized nonstop? I'm going very quickly through the 13 deployment steps. That is what I have on my agenda. For the guys who do not know me, my name is Ron Meijer. I'm on the Nonstop platform since 2000. I'm located in the Netherlands, close to Amsterdam. I founded in 2007 the company which I'm running today, Continuous Nonstop IT Solutions. And next to that, yeah, a second, call it brand in 2015, the Nonstop Academy. So the Nonstop Academy is in fact Continuous Nonstop IT Solutions. We are indeed an HPE Silver partner, in fact, a business partner and a technology partner. And today, we are responsible for delivering all the nonstop education in North America, South America, Mid-America, and EMEA. And that is what we're doing. So my exposure to virtualized nonstop. In fact, I started with virtualized nonstop around 2016, 2017. HPE announced at that point in time virtualized nonstop on OpenStack. You maybe heard about it. Today we are running virtualized nonstop on VMware, but it started with OpenStack. So at that point in time, we acquired our first hardware, something like 4 PowerLion servers, all the necessary PCI cards, add-ons, the Rocky switches which you need, and we start building our first virtualized nonstop. And that was not easy. The first setup, I think it was the second system next to the development systems in the world, and it was not easy to set up, but it was doable. We did it run. And in fact, the storage which we used at that point in time was a virtual storage array. In fact, a pair of them, one for the primary disks and one more for the mirror disks. So since that time, we are working with virtualized nonstop. And indeed, in 2018, we start working with virtualized nonstop on VMware. And we noticed it's much, much easier to set up. Yes, you don't have to have much knowledge about OpenStack, Linux, and so on to make it run. It was much, much easier. We also found out a couple of other things because over the years, we bought more and more hardware. Other storage, for example, today we have MSA 2050 storage. We do have XP boxes. We do use internal storage. And indeed, in the past, we had VSA, the virtual storage arrays. So over the years, we built up some experience with the different type of storage you could use with virtualized nonstop. And we noticed, for example, the VSA is nice, but it's slow. Yeah, it's too slow, in fact. We didn't like to use the VSA on virtualized nonstop. Today, we mainly use the MSA 2050s, and they are performing pretty well. They provide 10 gigabit iSCSI, and we do have one for primary disks and another one for the mirror disk. And it's you can use solid state drives, you can use HDDs, and that's a pretty nice piece of hardware. Of course, it's not high-end like XP storage, but it's nice to play around with. Today, indeed, we do have 6 virtualized nonstop kits in our lab, in our data center, which we use for education purposes, but also to play around with and to gain knowledge. For example, we do have today our first kit running on VMware 7.0. So till now, HPE only supports virtualized nonstop on VMware 6.5 and 6.7. But I can tell you already, coming with AL 2106, you can also run virtualized nonstop on VMware 7. So before, in fact, it is even launched, we have to get familiar with the technology, what is different between 6.5, 6.7, and 7.0. So our first kit is already running on 7.0, and it's not much different. Now, I have to tell you, HP did a huge job, a great job on improving, in fact, the whole deployment architecture of a virtualized nonstop. So there's a lot of new stuff coming with AL 2106, really a lot of stuff. And again, we have the luck that nobody can play around with it. So what happened? Indeed, something like a year ago, I got a call or an email, I'm not sure anymore, from HPE, and they asked me if I could help to bring up a virtualized nonstop system for one of their partners, Fortech Software. And in fact, yeah, we didn't saw any objections. I didn't saw any objections because we built these kits many, many times. I think in our data center, we have built from scratch at least, I would say, 40 installations. Of course, we have only 6 kits today. That's true, but we practiced. So we destroyed again a kit and build it up from scratch with a different configuration or different hardware. So we did it many, many times. And I thought, okay, we can do it. So we start talking about the project. And yeah, indeed, we started with a conf call about the requirements and kick off the project. In fact, this is the timeline. In June, on June the 6th in 2020, we had our somehow initial call. So how are you doing? And how is life? We would like to have a virtualized nonstop. And we start talking a little bit about, yeah, what do you need and what do you want? What is your budget and so on? And we had many, many more calls. Yeah, or many more calls. I think in total, we maybe had something like 6 calls and a couple of emails where we exchange information about the hardware we just needed and how to do this and how to do that. And indeed, on September 16 last year, the hardware arrived in the Netherlands. Indeed, I did not start working directly on this kit because there's other work to do, but I'm not sure anymore. I think a week later, we plugged in the hardware and tried to bring up the ProLiant servers. And we had a couple of questions. How do you like to configure this? How would you like to have that? And in total, it took something like, as you can see, 6 weeks max. When Shaw picked up the hardware, the kit at our data center in the Netherlands and brought it home. And we didn't work on the system for 6 weeks. I mean, we did something and we waited, and we did something again and we waited, but the total thing took something like 6 weeks. I think the total work we put into it is something like 5 days, 5 working days. So during our calls, we talked about the configuration, and Shaw said, okay, we would like to have 4 non-stop CPUs, but in the beginning, he said we would like to have an entry class, and later on we changed that, or he changed it in fact to high end. And that's not a problem. The hardware, in fact, the microprocessors could handle the high end, except we didn't have sufficient memory. So when the hardware arrived at our place, I had to order some additional memory to expand the ProLiant service to make it a high-end system. 2 storage claims, 2 IP claims. Vortex software does not require any kind of interface bonding on the IP claims or claim-to-claim failover, because if you require this, you need different hardware. So you need to discuss the requirements of a virtualized non-stop before you order any hardware, because otherwise you maybe cannot build what you actually want. And indeed, internal storage, no SAN, no external storage, only using the internal storage. On this picture, you can see, in fact, the architecture of a converged system, and I think you all recognize this. In fact, this is a non-stop X system. It could be an NS3, an NS7, or an NS4, NS8 system. Now, every resource endpoint, like a CPU or a CLIM, is a physical box. It could be a BL460C, it could be a DL client server, for example, today with the NS4, NS8 systems, with microprocessor, with some memory, RAM, and of course a connection to the X and Y fabric. But each green bordered box over here is a piece of hardware. So by looking at this picture, you can see that we have something like 6 boxes, 6 physical boxes to build this 2 CPU non-stop server. Next to, of course, the hardware which you need for the InfiniBand switches and the maintenance LAN and the non-stop system console and so on. And that is what we know, of course, from converged systems. They became smaller over the years compared, for example, to NS series systems or the S series systems, but still, there are quite a lot of hardware boxes. Now that, of course, is something we can replace nowadays by virtualized non-stop. And here with virtualized non-stop, each endpoint, each non-stop resource like a CPU or a CLIM is a virtual machine. So a virtual CPU, in fact, this picture shows me 2 of them, 2 virtual CPUs. Then I do have 2 IP claims, I have 2 storage claims, and I do have even a virtualized non-stop system console. Also, these resources are connected to each other by an X and Y fabric, which is not ServerNet, which is not InfiniBand, but RoCE, RDMA over converged Ethernet. Indeed, also my virtualized non-stop requires some kind of storage, here shown as a SAN storage, like an MSA or an XP box, and you need some kind of network connectivity for your customer connections, external IP network. To make this run today, you need VMware. And what you need first is the VMware hypervisor, and that's the ESXi product. That's something you need. Without ESXi, no virtualized non-stop. Next to that, you need vRealize Orchestrator. An orchestrator is the orchestration tool to run the workflows which we have for virtualized non-stop to deploy a virtualized non-stop system. vRealize Orchestrator does require vCenter. So we need vCenter and vRealize Orchestrator to deploy a virtualized nonstop system. But once it is deployed, once the virtualized nonstop server is running, you don't need them anymore. You don't need any more vCenter or Orchestrator. I have to tell you, if you do not have them anymore, so if you only have ESXi in place, that means that you can never expand your system or change your system, add disks or something like this. I mean, you could, there are many other ways to do it, but you cannot use HPE's workflow. This is what we have decided to do, in fact, with Vortex software. They're not having vCenter, they do not have vRealize Orchestrator. They only have ESXi. That's the reason why the kit came to our data center, because what we did is we hooked it up to our infrastructure where we do have vCenter and vRealize Orchestrator available. And we use that to deploy the system, for Vortex software. So ESXi, that's required because that's the hypervisor. That's the guy who makes it possible that we can do virtualization. Now, hardware resources. What do you need to build a virtualized nonstop? You need servers. Now, we have chosen for Polion servers, but it could also be another brand. Of course, the servers do require certain specifications. Then we need Rocky switches. If you stick with only 2 hosts, so if you have only 2 Polion servers, as the kit with Vortex software, there's no requirement for these Rocky switches. They are pretty expensive. So this kit, the kit which we built for Vortex software, doesn't have these Rocky switches. SAN storage is also optional because you can choose to use internal storage. So what we have at the end is in fact only a pair of Polion servers. And I believe I have this on the next page. No, not really. I still have a summary of what we need to build a virtualized nonstop. Indeed, we need hardware. I already mentioned that before. Yeah, hardware which can run VMware virtualization and can run virtualized nonstop. Not all hardware is suitable. Yeah, so be aware. You cannot select every Polion server which is around. You cannot select every microprocessor which is around. Then we need storage for my virtual machines and for my nonstop volumes. At the end, you would like to have a dollar system, a dollar audit, and so on. So you need storage. And how much storage you need, yeah, depends on your requirements. My virtualized nonstop, a small system like the Vortex software system, does require something like, I would say something like, now I have to estimate, I would say 0.5 terabyte of, let's say, internal storage to run the virtual machines. So to have a repository, to deploy your virtual machines, and to have the internal disk of your virtual machines. And that number is wrong, guys. I was counting wrong. I was counting from my head. It's not a 0.5 terabyte. I think you need something like 1 terabyte. Yeah, that is what you need to run your virtual machines in a small system. Then we need IP networks, networking. We need networking for managing VMware. We need a network for our nonstop maintenance LAN. And we also need a network to access the nonstop server. Otherwise, the nonstop server doesn't have any use. We have to access the applications, the nonstop. And then indeed, we need software. I already mentioned that we need the hypervisor, ESXi, vCenter server, and orchestrator. And I told you the vCenter and the orchestrator we can eliminate if we do not require future modifications. What do we need more? We need software. You have to order your virtualized nonstop with HPE, but you will not receive a box which contains a nonstop server. No, you will receive emails. And in these emails, you'll find links where you can download your VMDK images, for example, your virtual machine disk images. We need one for our CLIMS. We need one for our dollar system, the SUT. Next to that, we need the halted state services image file. We need the nonstop system controller installer DVD. We need the licenses from HP because without the licenses, you cannot run it. And you need the deployment tools. And what we need for sure is the vRealize Orchestrator workflow tool. In fact, it's a package which you load into Orchestrator, which provides you the workflows. And optional, you could also install a plugin into vCenter, which gives you a more graphical option to deploy your virtualized nonstop. And what we need more is a Windows Server 2016 license for our virtualized nonstop system console, a standard license. So what do we need? What does my hardware need to provide us to build a virtualized nonstop system on VMware? Now, first of all, our logical CPUs, they need cores. And how many cores do we need? For an entry class system today, the maximum number of cores for an entry class CPU is 1. If it would be a high-end system, yeah, you can choose between 2, 4, or 6 cores. Now, Shaw has chosen for a high-end system with 2 cores. So 2 cores. Memory, indeed, entry class system can have 32 up to 64 GB of memory, every number in between you. So you can also have a logical CPU with, let's say, 51 GB of memory, but a high-end CPU, you can see over here, does start with 64 GB. Then we need IP claims, maybe telco claims. We need for sure storage claims. So each of them also require cores. The minimum is 4. This is what you can choose depending on how you're going to use these claims, but 4 is the minimum. And for storage claim, if you would use volume level encryption, you need at least 8, or you need 8. And then the memory, IP and telco claims, they require 16 GB of memory, and the storage claim 4 GB. Your Windows 2016 virtualized nonstop system console requires 8 GB of memory and 2 cores. So by knowing this, you can calculate which microprocessors and how much memory you need in your client servers. There are rules for that. You need also a couple of spare cores and spare memory to run the VMware hypervisor. So do not think that if you have 2 CPUs and 2 CLIMs, that 1 + 1 + 4 + 4, 10 cores is sufficient. So 2 cores for the CPUs, 1 core for each entry class CPU, 4 cores for an IP CLIM, and 4 cores for a storage CLIM makes up 10. Is sufficient? No, that's not true, because there's overhead. There's overhead from VMware. VMware also requires a few cores, and if you do not have them, it will not run. So you need more than 10 cores to build these small entry class systems. So what do we require in our ProLiant server? The ProLiant server, for example, which Vortex software board. We need microprocessors with sufficient cores, memory. We need internal disks for ESXi, so for the hypervisor. We need disks for the nonstop. So the dollar system, the dollar DSM-SCM, and so on. And we need network adapters for VMware, to manage VMware, for the maintenance LAN, for the customer LAN. Then we need the Rocky adapters, yeah, because we have to create an X and Y fabric. So the 2 fabrics which we have in each nonstop server. And for that, we use Rocky adapters. And there are different flavors available. So you can choose slow adapters, fast adapters. There are different ones available. We need power supplies. We need fans. So by knowing all this, by knowing what you need to build a virtualized nonstop, how can you build a virtualized nonstop? You need that ProLiant server. And what you could decide is to put everything in one ProLiant server. This technically does work. You can do this. You can build one virtualized nonstop server with one large ProLiant server. I'm sorry, I have to disconnect for 1 minute. Give me 1 minute, pause, please. 1 minute, please. Interruption, guys. I'm sorry for the interruption. I had to open the door very quickly. So what we see on this slide is in fact a virtualized nonstop server running in one physical box. But of course, this is not really nonstop, because when we have a problem in this box, your whole virtualized nonstop will go down. Second, the hardware is also pretty expensive. For example, over here, we see a deal 580, and I think it is a Gen 10, a deal 580 Gen 10, but one deal 580, sorry, Gen 10 is much, much more expensive than two deal 380s, for example. This guy has internally 4 microprocessor sockets. I'm not sure it can go up to a couple of terabytes of RAM. And that's nice, of course. For a development system, you could consider to use this, but still, if something goes bad, even when a memory DIMM goes bad, yeah, your PoleIron server will go down and your whole virtualized non-stop will go down. So this will not bring you much redundancy. That's the minimum redundancy, and it's not really non-stop thinking. So what you could do also is, yeah, you could buy a lot of PoleIron servers, that each of your PoleIron servers, yeah, runs one virtual machine. Also, that is technically possible. And this is close, of course, to something like a convert system. So one box for my first virtual CPU, another box for a second virtual CPU, and then for my CLIMS. But again, this is quite expensive, most likely more expensive than a convert system. So it's always the trick to find the right balance. Yeah. So what would I like to have? What kind of redundancy would I like to have and what I would like to invest? Here, for example, we do have a 4 CPU system. So 4 virtual CPUs, which we house on 4 physical boxes. But indeed, because of virtualization, yeah, these boxes can run more than one virtual machine, more than one non-stop endpoint. So like a storage CLIM, an IP CLIM, and so on. So finding the right balance, that's always important. Make it non-stop, yeah, and of course with the least hardware possible. This is how we did it with Vortex software. 2 PoleIron servers, 2 DL380s, Gen 9s with 8 disk-based slots, 2 hosts, you can see. We have 4 CPUs. The odd CPUs we have in the second, and that's the typo in the slide. It should be CPU 1 at the left button, CPU 1 and CPU 3, the odd numbered CPUs in the second host, and the even numbered CPUs in the top host. This is also not really non-stop. And I have to tell you, in the first place, the workflows which we have from HPE do not allow you to do this, but there's an option in there. So you can change what we call the redundancy level. And if we change the redundancy level, we are allowed to create multiple CPUs in one physical box. But it's true, when the first host goes down, the first PoleIron server goes bad, then you will lose 2 CPUs. But your system, in fact, is still accessible. You have still CPU 1 and CPU 3 operational. So in total, we have 4 CPUs, each 64 GB, high-end CPUs, dual core, 2 storage CLIM, 1 storage CLIM per host, 1 IP CLIM per host, and 1 virtualized non-stop. So quite a nice setup. If you do use internal storage, as we did with the Vortex project, then your non-stop volumes cannot have 4 paths. This is just not possible except when you use virtualization technologies for storage. VMware does offer that, but it's not really, yeah, this doesn't really perform very well, but technically possible. And why is that? Because, yeah, one of your, I'm going back one slide. The storage in host 1 is physically not accessible by the hardware in host 2 and vice versa. So a disk cannot have 2 paths except when you use a piece of software to handle this. And again, there are products available, storage virtualization. There we go. But in this case, we have decided not to use that. And we just have 1 path per disk and 2 paths per mirrored volume. Only the primary path is there and the mirror path is there for the mirror disk. One more, when you start building these systems, you have to make for yourself a couple of schemes. Schemes, for example, about naming convention, because you will have ILOs, you have ESXi hypervisors. They all need to have a name. And yeah, you have to come up with something which is logical, which you can remember, which you can use. So here you can see, for example, the naming convention, which I use in our data center and also used for Vortex software. Their system, by the way, does have the name tag 4. And that system name is part of, in fact, the network name for the ILO or the ESXi management network. So step one, we receive the Proliant servers, we power them on. And what I always do when I receive hardware, we bring it back to factory default, especially refurbished hardware, because there are settings there which are maybe hidden, which are not reset by the supplier. So we bring them back to factory defaults. Next to that, after that, we're going to configure the ILOs. The integrator lights out of these boxes with a static IP address and some credentials. And you can use for that a crash card, but other options. Indeed, create also an IP address scheme first. Make something which you can remember, because a virtualized nonstop kit has quite a lot of networking and IP addresses and network names. And you have to use them in a logical way. Then we start updating all the firmware. We cannot update all the firmware from, for example, the ILO of the Proliant server, or using PSP, the Proliant support package. For example, the Mellanox adapters that need to be updated from VMware itself, from the command line. So we, at this point in step 2, we did not update all the firmware, but all the firmware which we could update. Then we connect the ILOs and VMware to our infrastructure. So we do the cabling. There's nothing running on them yet, but we just hook them up so that we have the cabling in place. Again, there's no need to run vCenter or vRealize Orchestrator on the Vortex software Proliant servers, because we have it in our infrastructure. This indeed brings that limitation that I cannot expand or change the system in the future. Then we have to use the smart array configuration utility to configure the RAID, the disks. And we have chosen here for a RAID 5 configuration. Also, both Proliant servers are configured exactly the same, except that they do have maybe a different name for the ILO and the network. Now, once this is done, and this should be step 3, we boot that Proliant server again, and we are going to configure the Proliant server with the necessary settings for virtualized nonstop. So we have to enable, for example, virtualization technology. VTX, that's the Intel virtualization technology, which you can use for actual virtualization, to run multiple virtual machines on the same hardware. VTD, that's also an Intel virtualization technology, but that is a virtualization technology for hardware, for PCI, for example, PCI adapters. And VTD does include Azure IOV, single root IO virtualization, which we does require for virtualized nonstop. We enable Azure IOV on our Rocky adapters. We talk about the 2 adapters, one per Proliant server for my X and Y fabric connectivity, and we're changing some other things like the power profile, because a Proliant server can run with a maximum performance with no power saving. It can run with a power saving option, so you save power, but also the nonstop server will run slower. So you can make changes in here. And again, both the Proliant servers are configured the same. Then we're going to install VMware ESXi on both Proliant servers, and this is pretty straightforward. Then once ESXi is running, we have to use the ESXi shell to install the necessary Mellanox drivers and packages and configure them. That's all done from the command prompt. So what next? We are now having VMware ESXi in place. Now we are going to log on to ESXi, which does provide us a web interface. And then we're going to create our internal data stores. The data stores is the storage where we actually are going to store our VMDKs, so our software which we require to deploy CLIMS and our dollar system, but also at the end where we are going to create our $DSMSCM and $audit and $data1. It will be all there. So we create a data store in VMware. And once this is all done, we are going to add the 2 Proliant servers to our vCenter infrastructure. So there are maybe already 10 Proliant servers part of that vCenter infrastructure, and we're just going to add 2 more. And you can do that. And once the 2 are added, then you can start building that virtualized nonstop system. Of course, before we have made a plan how we are going to configure these ProLiant servers and so on. Now, first of all, because we only have 2 hosts, there's no requirement for a maintenance switch. You can see the fat, thick red line over here, and that's my maintenance line connection between the 2 hosts. As I told you before, we do not have vCenter in place or vRealize orchestrator, so there's also no need to connect the ESXi connections to something else. I mean, they are just living there, and you can hook them up to your own infrastructure so that you can manage your boxes, but they do not have to be connected to each other so that we can manage them centrally from vCenter. So you see that here with the green lines over there. The green lines are my management network connections. Then I do have the actual non-stop network connections, ETH1 up to ETH4, and they are configured on both hosts in the same way. So the 4 ports on the embedded card, network card are used for that. And we have one connection to the vNSC, the virtualized non-stop system console, so that you can make an RDP connection, a remote desktop connection to your non-stop system console. Then the pink lines over here are my Rocky connections, my X and Y fabric, which again are just a straight connection between 2 hosts because we do not require these switches with 2 hosts. So a very basic, simple setup. Then we're going to configure the networks in ESXi/vCenter. You can do either ESXi or vCenter. You have a choice over here. So you have to create the working networks, the non-stop maintenance LAN, and the Vortex software non-stop network connections, ETH1 up to ETH4. Then we have to create a JSON file. The JSON file is the input file for the workflows in vRealize orchestrator to deploy a virtualized nonstop, which does include, for example, the system name, the system serial number, the expand node number, what kind of a system, high-end or entry class, the number of CPUs and the memory size, the number of storage and IP claims, including the number of cores and the network connections. We have to enter the maintenance and IP addresses, and indeed the level of redundancy. We have to change this in the JSON file, otherwise the workflow will not allow us to have 2 CPUs per ProLiant server. Now here you can see a snippet of the JSON file, the beginning in fact, where you can see the system name, the system serial number, and the whole JSON file is maybe 3-4 pages in size, because below this you will have the CPU definition, the CLIM definition, and so on. So this is the JSON file. Then it's time to deploy a virtualized nonstop system console, and that's not really special. You just install a virtual machine with Windows Server 2016, and on that Windows Server you install, of course, your NSC installer DVD, which comes with all the OSM tools, the system startup tool, the configuration tool, and so on. And indeed, because we do have this external connection available, the vNSC connection, you can access that console from your own infrastructure. And from there, of course, you can access the maintenance LAN, and you can co-load the nonstop server and so on. So indeed, once we have the JSON file ready, we can kick off that workflow to deploy a virtualized nonstop by using vRealize orchestrator. And the workflow will execute, and then there are no mistakes in the file. Your nonstop server will be deployed. Then we're going to configure some more settings in VMware, because by default, VMware does not power on your virtual machine. For example, after a power off, I wanted to have a kit, which indeed Shark could power on. Just push the power button, and after a few minutes, I said 15 minutes, the system should be operational. So we have to configure a few of these things: automatic power on, time synchronization. We wanted to eliminate some unwanted warnings, and that is what we do in this step. And then we're going to configure the virtualized nonstop with the system configuration tool, which is one of the final steps in the whole deployment procedure, to make the virtualized nonstop run. We have to go to both storage clips to approve the $system disks. Otherwise, they're not known. They need to have a LUN number. Then we are going to cold load the nonstop server. And once the nonstop server is running, we configure the remaining things like the nonstop volumes. I think we have 14 300 GB data volumes, and then the standard $OSS, DSMS, CM, $audit, and $system. And so 18 disks, something like that, this mirrored volumes in this small system. And that's it. So then we did the technical information, documentation with all the IP addresses, log on credentials, and the documentation does include the installation procedure, startup procedure, some considerations, and a shutdown procedure. I think in total 4 or 5 pages. Just line by line, what do you have to do? What do you have to do to bring the nonstop server up? What do you have to do to bring it down? For example, the installation procedure. Connect both the walkie cables, connect the maintenance cables, connect the power cables, power on, and go out for a cup of coffee. And once you come back, you could indeed access the virtualized nonstop remotely and co-load it. That is the final step, the documentation. And that's all I have. And I know I'm running over time, but I'm sorry about that, guys. I hope I could keep your attention. So are there any questions? I'm not sure if I can see somewhere the questions.
Question for Sean, actually, if he's still on.
Yeah, I'm here, James.
I'm sorry that I went over time.
Right. With the COVID restrictions last year, did you have any sort of challenges with the transport getting to Holland and back?
Interesting you say, actually. So on the day that I went over, as I was going over, the news was on that they're actually going to close France. So yeah, I was literally. Luckily, we kind of knew this might happen, so I bought an unrestricted ticket on the train. You know, I forget what they call it now. But yeah, I can basically get on any train straight away. It was like about 3 times the cost, but I didn't want to get stuck. And yeah, the queue at the border was unbelievable. But luckily, I got the right ticket, so I got straight on. And I actually got back to the UK the day before they closed France.
So that 3 times the cost train ticket was included in the 13,500.
It was actually, yeah. So if you travel coach, you can get it cheaper.
Okay. Thank you very much, guys. Thank you to Neil. Thank you to Sean. Thank you to Ron. I'm sure you all agree that was an extremely interesting presentation. I have been messaged by various people about the timetable, but as I've said in the notes, I was loath to interrupt Ron, as A, that was so interesting, and B, it wasn't really Ron's fault because we inserted Neil Davis at short notice. So what we will do is commence the next sessions without delay, allow those to run into lunch, and then if it's okay with everybody, we'll just start the afternoon session at the same time at 13:30. There'll still be time to probably 20 minutes, 25 minutes or so to grab a sandwich, the Uber Eats, if that's what you've ordered today, or do what you need to do. So without further ado, the next 2 sessions are in track A. Zypro, our friend Steve Roy will present multi-factor authentication for nonstop. You already have it. And in track 2, TandSoft, Jack DiGiacomo, shopping for software before you buy, read the label. I'll open up those 2 breakout rooms now, so you should be able to choose the room that you go to. Kevin, if I can ask you please to record the TandSoft session, and I will record my good friend Steve Roy. Thank you very much all. Any questions? Cool.
there, John.
Hi there, Steve. The floor is
Um,
yours, sir.
So do I just need to share my screen? Is that the deal?
Yes, I have made you a co-host.
Thank you, sir.
You should be able to do that. And that's showing perfectly. Over to you, Steve.
Excellent. And yeah, I can curtail this to less than half an hour. So good afternoon, everyone, and thank you, BITUG, for setting up this virtual SIG. And let's hope that the next event will be in person. My name's Steve Roy. I'm the account executive for Zypro across all of EMEA, and I'm based in High Wycombe in the UK. Today, I want to talk about quite an important topic, which is multi-factor authentication and how you can implement it in your non-stop environment. I'll set the scene and then give you some ideas about what you can do to protect yourself on the non-stop. Most of you, I think, will know about Zypro. We're coming up to being 40 years within the non-stop environment. So been around for a long time. We're based in Simi Valley in California, which is starting to open up. For the last year and a half, we've worked virtually, although the company has grown with people doing virtual interviews and stuff like that. So we've added mainly to our engineering and development and support staff. Our expertise, as you probably all know, is in the cybersecurity space, in compliance and database management. We're worldwide. We've got very strong partnership with HPE, and that partnership is growing and strengthening all of the time. We also have a number of other very important security partnerships with people like CyberArk and SailPoint. These are things that are probably within your environments in the wider enterprise, and we're the only certified integration for non-stop for those technologies. So if you have people approaching you saying, what are you doing about your CyberArk integration, we're the people to talk to. And we've also got some patented security intelligence technology that's taking us to a deeper and deeper level of security. And what we're trying to do really is become your trusted security partner rather than just a vendor. And we're looking at solutions that will help you integrate the non-stop, modernize it, bring new innovation to it as well. We'll talk about some of the strategic partnerships on the next slide. But yeah, we've got 700 plus customers worldwide. Globally, we've got 24/7 support, multiple languages. Yeah, a good, solid organization, and we've weathered the pandemic pretty well in the last year and a half. And for the last 10 years, any of you who have bought an HPE system will have got Zypro products included within the operating system. So the HP relationship, very important from that point of view.
Banana comparison, or when we say we're blazing fast, we mean it. So this presentation will emphasize the value of label reading for our most popular solutions.